to invest. If you give me 10,000, I will spend it. Go for shopping, go for holiday. Isn't it? Okay? Because I can invest. Can you see the feedback? Okay, thank you for the response, class. Okay, back to our slides here. Okay. Um, it is a wise choice, okay, when you choose to have this $10,000 today, okay, it is because for certain reason, okay. Perhaps, if you have that money today, as what your friend said, you can save it, you can invest it, so that you can earn more in the future, isn't it? Okay. So this is because of the effect from the interest and also time factors, okay, that can make your money grow. So what is the real concept of time value of money means? So it defines the TVM as a dollar in a hand today, a dollar, then the same dollar that to be received in the future. All right. Why? Because you can save it, you can invest it, you can even spend it. Okay. So that when you save, when you invest, you can have a returns on investment, you can earn interest, okay, and the money can grow in the future. So essentially, I would say that money has earning power due to the interest from the investment, okay? So in the real world cases, perhaps the concept of TVM will be applied on, bank savings account where the bank will offer you a certain interest, if you keep your money with them in the accounts, and then perhaps from taking loans, in fact, from your educational loan, okay? Perhaps this concept is applied, okay, when you start to taking any kind of loan, and perhaps used by the economists, okay, to calculate for the purchasing power or also inflation. All right. So under this concept of time value of money, we have two main components. Is PV, present value, and the second one is the future value. All right. So what does it mean by present value? Is a value today of a sum of money that you will receive in the future. So you want to know how much does it value today? All right. So in other words, it shows that how much a future sum of money is worth today. All right. After you have considered the interest and also the periods. Okay. So talking about the future value is a value of sum of money in the future, okay, at a certain interest rate. All right. In other words, you want to know how much your money will grow in the future if you have like 100. Okay. So in the process of expressing the value of present in the future, so we call as a compounding effects, compounding process. You want to know how much you will earn in after 5 years. How much is the value of your money in after 5 years, perhaps? Okay, so this is what we call compounding process. Okay, uh, inversely, okay, if you want to know the value of future in the present, okay, the future value in the present, meaning to say, let's say you will get, $1,000 at year 5, right? How much this $1,000 would value today? All right, this is what we call discounting process. All right. So next, we're going to discuss about the importance of time value of money concept. This is very, very crucial because it will help the manager making informed and sound investment decisions. Okay, it will tell the manager the right time to make investment, worth investment. Okay, either you can wait today, either you can invest today or you can just wait for a couple of days. Okay, it tells you the right time to invest. And this concept also is very important for you to use as a foundation, to understand further about the concepts of interest rates, inflation, perhaps how to calculate loans, okay, and also very important for your retirement planning, all right? And this time value of money concept is used for business valuation, Okay, use for business valuation. You want to know how much is your business valued today. Okay, and perhaps we could help you to decide in the capital budgeting decisions, you know, and also help you much in the personal financing decisions. You as a student also, you can use this concept, this knowledge, okay, perhaps to help you to manage your finance more clear, right? So these are the examples that we have just discussed earlier. Okay, perhaps if you saving some account, some money in the bank savings account. Okay, for example, you have $500 that the banks actually promise you to pay 4% interest annually. So this money will grow to certain amount in the future, isn't it? Okay, talking about loans, educational loan, personal loan, car loan, housing loan, you know. So all these things is actually applying this concept of time value of money. All right. And last but not least is purchasing power. Perhaps a dollar that perhaps $1,000 that you have today, okay, will not be similar. Okay, the value will not be similar in after 5 years. You know why? Perhaps because of the purchasing power, okay, has reduced due to the inflation. All right. So next we look at the timelines. So as you can see, these timelines actually helps you to understand better and to see much more clearer about how to solve, you know, some of the problems in calculating the present value and future value. All right. So as you can see on top of here, we have this we call N. N is means years. Okay. So down here is a cash flows. Okay, this is a cash flows in the monetary terms. And you have the effect from the I interest for perhaps 3 years in these examples. Okay, so how to draw for $100 lump sum due in 2 years? So if the question, okay, tells you about $100 lump sum due in 2 years, so this is how we draw the timelines. Okay, we put the lump sum $100 at year 2. Okay, we have 2 years here and the effect from the interest. How about the 3-year $100 ordinary annuity? Talking about annuity, what is annuity? Means it is a series of payment. Okay, payment, series of payment or equal payment. Okay, series of equal payment, right? So this is an equal payment of $100 each year you will receive, okay, for 3 years, okay, with the effects of the I here. Also, you can perhaps draw the timelines for uneven cash flows. Okay, perhaps you will receive, you know, different amount of cash flows every year for 3 years. So this is how we draw for the timelines. Okay. These are the terms that commonly used under this topic. You will find about, you know, the PV, future value, cash flow terms, interest, and also number of periods. Okay, so you use all these, you know, terms and this in this concept. All right. So next we move to the simple versus compound interest. Okay. To understand the time value of money, you need to differentiate between the simple interest and also the compounded interest. So let's see what is the difference. So simple difference is actually defined as interest earned only on the principal amount. Okay, this is very straightforward, only on the principal amount. Okay, whereby this compounded interest is interest earned on both the principal and accumulated interest of the prior periods. So as we can see from the graph here, the compounded interest is much more exponential, isn't it? Compared to the simple interest, which is more linear. All right. So let's look at this example. Suppose that you deposited $500 in your savings account that earns 5% annual interest. So how much will you have in your account after 2 years? Using simple interest and using the compounded interest. So let's see how they calculate them. Okay, first, when you calculating for the simple interest, it is very straightforward. Okay, the interest 5%. Okay, we will calculate on the principal amount, which give you $50 because you keep your money for 2 years. In other words, in a year, perhaps $25. You have 2 years, $50. So balance at the end of year two, $550. The principal plus the total interest. All right, so this is very straightforward. When it comes to compounded interest, you need to calculate for the interest earned year by year. Okay, let's look at for the first year. Okay, you have your beginning value or principal value of $500. 5% on this principal is $25 for your interest, and at the end of the day, you will earn $525 total. All right. And to calculate for the second year interest, you need to have this accumulated principal and interest at the beginning value. Okay, of course, 5% on this principal value, 525, okay, will give you extra, slightly extra $1, isn't it? $1.25. Okay, so total at the end of the value, 551.25. So compared to this method, simple interest, you will earn extra $1.25, isn't it? This is because of your principal amount has become grower and greater. Okay. Okay, talking about the future value, we have so many methods, okay, to calculate for the future value. Okay, first thing first is using the formula. What is the formula to calculate for the future value? This is the formula class. Future value is equals to present value times 1 plus I power of n. Okay, if you're calculating for 1 year, so your n is become 1. If you're calculating for year 2, so your n is become 2. If you are calculating for year 3, your n is equals to 3. Okay. If you want to know, how much you earn, this savings of $100 at 4% deposited for 3 years. So this is the ending value that you will receive using the compounding interest method. Okay, $112.49. Okay, we also have other methods for solving for the future value. Okay, perhaps we can use the calculator, we can use Excel, we can use the apps, okay, and even the interest factor table. All right, so I believe that the calculator is I don't think that people nowadays use the financial calculator. This is not the statistic calculator. This is the financial calculator. And I'm telling you, it is quite pricey, quite expensive, okay? And nowadays we have this what you call smartphone, isn't it? So you can just download from the apps, okay, to have this kind of financial calculator, all right? And perhaps if you have your Microsoft Excel, also you can solve the problem, okay, using the Excel. And also you can have this interest factor table to solve the problem. I already shared with you the interest factor table together with the slides, okay? Perhaps you can ask from your lecturer if you don't have any, all right? Okay, talking about solving the problem using the financial calculator, okay? You need to key in some inputs, okay? Key in some inputs for you in order for you to calculate for the future value. All right, you need to have this information class. You need to have this information. Or you can just use the Excel formula. Okay, you just type into the cell of the Excel. Okay, and they will calculate it for you for the future value. All right, and then you also can solve, this future value problems using the apps, okay? Perhaps you can just go to the app store and, I would suggest you these apps because this is what I suggest to my students here as well. I believe, perhaps you cannot bring this smartphone into the exam hall, isn't it? But just use it as a, perhaps as your buddy to help you confirm the questions during your tutorial, you see? All right, and the last method here, perhaps using the interest factor table. Okay, so this is just the extracted one. Perhaps, I already gave you all this, okay? Okay. So this is what we call interest factor table. We have altogether, we have 4 kinds of interest factor. Please be careful. Okay, we try to plug out the figures from this table. Okay, we have present and future value table. Okay, we have the simple interest, direct one, simple interest factor table. And this is future annuity. Okay, future annuity. And talking about the present value, this is a present simple interest, or this one, present value of the annuity. So altogether, you have 4 kinds of table, okay, that you can use to solve the problem. All right. Okay, let's try this, class. Suppose that you deposited $2,000 in your savings account that earns 3% annual interest. Okay, so how much will you have in your account after 3 years? So 3 years is n equals to 3, isn't it? This is your PV, present value, the money that you have today, you want to deposit with the interest of 3% annually. All right. So using the simple interest is a very straightforward, isn't it? May I know how much is a simple interest for 3 years? The interest is equals to 3% times $2,000 times for 3 years, isn't it? So how much plus 180? Am I correct? First. Am I correct? $180? Am I correct? Simple, isn't it? This is only for interest. How about for the total amount that you will have after 3 years? Okay, so the principal plus with the interest, isn't it? So it's around 2180. Please correct me if I'm wrong. Did you get the same answer? Okay, good. How about the compounded interest? Using the formula is much more easy, isn't it? Okay, compounded interest, perhaps you want to know the future value of 2,000, 1 plus R, isn't it? Power of n. Okay, you can put R, you can put I, okay? As long as it is representing the interest, isn't it? Okay, so the PV here is $2,000 times 1 plus R is 3%. Okay, power of n for 3 years. So you have to settle in the bracket first. Okay, 1.03 power of 3, then it times with 2,000. How much will we get, class? 2. Can someone help me to calculate? How much do you get for this? Oh, sorry.
185.45.
Okay, 285.45. Am I correct, class? How about the rest? Okay, thank you for nodding. Thank you. All right. Okay, next is we move to the compounded n times in a year. Can the interest be compounded more than 1 time in a year? Yes, it is possible. Okay. The one that we calculated just now is compounded at annually, only 1 time in a year. So now we are moving towards a compounding n times in a year. So banks may actually offer you to compound their interest to be compounded at a monthly basis, semi-annually, quarterly, daily, okay? So what if the interest rate is compounded n times in a year for a duration of 3 times? In other words, what will it affect when compounded few times in a year? It will affect your I and also your period term. Okay, so let's look at this table, class. So let's look at this table. If your interest is compounded annually, so your M means only 1 time, and your interest and your period is still the same, because any numbers times with 1 divided with 1 is still the same, isn't it? But if your interest start to compound it semi-annually, okay, now your M is become 2. Okay, your new interest, you need to divide it by 2, and your new period, you need to times 2. Why? Because when it comes to annually, okay, this is annually a year. Okay, let's say your interest is compounded 12% per annum. Okay, per annum, this is we call nominal interest. Okay, nominal interest means they are actually looking at the annually. All right. So when your interest is compounded semi-annually, meaning every 6 months compounded once, every 6 months compounded once. So how many times compounded? So now your N is no longer 1, it's become 2, because 2 times being compounded. Okay. How much interest that you can compound it for each section or each period? So you have to divide it by 2. Okay, so every first half is 6%, another half is 6%. Make sure the total is 12% according to the annual term. All right. So if you're semi-annually, if your interest is compounded quarterly, okay, so meaning your M is equal to 4. Quarter means 1/4, isn't it? So every 3 months. So every 3 months. So you have to divide it by 4 for interest, and new period is times with 4. Same goes to monthly. Your M is become 12. Okay, to find new I and N, you have to divide and times with 12. Okay, for daily, okay, your M compounding effects now becomes 316 a year. Okay, to find new I, you have to divide it with 360. To find new N, you need to divide it at times with 360. All right, so this is how we convert, okay, where there is a compounded effects. Okay, next we move to the future value compounding process. Okay, let's look at this example. What is the future value of $100 that pays 8% per annum compounded quarterly for 5 years? So as you can see, the original nominal interest is 8%. Now this interest compounded quarterly, meaning your M is equals to your M compounding effect. Anyone? Are you with me, class? Okay, so quarterly here means your M is equals to 4. Okay, so new I is 8% divided by 4, then you have 2%, and you have to find for new N. Okay, so 5 years here, 5 times 2, isn't it? 8 times 2, sorry, 5 times 4, isn't it? So it's become 20. Okay, so just substitute those new figures, okay, in the formula to calculate for the FV. So you find that your future value of this $100 would be $148.59 after 5 years. All right. Okay, let's try this, class. Let's try this. What is the future value of $500 that pays 6% per annum compounded monthly for 3 years? Anyone? FV, it's equals to PV 1 plus R power of N, isn't it? $500, 1 plus R. This is compounded monthly, so your M effect is 12. So for I or for R, which is 6%, 6 divided by 12, compounding effects. Power of N is, how much is now? Sorry. 3 years. So 3 years times 12. Okay. So this is 0.05. Okay. And power of 1.05 power of 36 times with $500 Can I have the answer?
Miss,
Okay. Yes, Honey, please.
let's try. The result is 597.81.
597.81.
81.
How about the rest? Did you get the same answer? The rest?
Sorry, Miss. I thought it's quarterly, but it's but it's monthly, right?
This is monthly. Okay,
Oh,
monthly.
okay. Okay. Sorry.
Never
My
mind.
fault.
It's okay. It's okay. Just try to recalculate. So the answer is, so I considered this is wrong. Okay, can I have the correct answer, please?
Maybe it's 2,895.90.
2895. Wow, that's such a big amount. How about the rest? How about the rest, class? Oh, this is the correct answer. Oh, really? Okay, for 3 years, because compounded monthly, isn't it? Compounded monthly. Okay, the other way on how to solve this, if you don't have like perhaps the statistic calculator, perhaps you can use the table. All right, you can use the table. So now you have your new your new N is 3 times 12 is 36. For I, you have your 6% divided by 12. So you have 0.05. Oh, okay. I don't think that, sorry, 5%, isn't it? 6 divided 0.5%, 0.5%. I don't think there is a 5% here. Okay. The lowest we can go is 1%. Okay. The lowest we can go is 1%. There is no 0.5%. Perhaps you cannot use the interest factor table. Okay, so just solve them using the formula. So this is the correct one, class? 2000 plus? Is it the correct one? Okay, later you find it out. Okay. So next is, will it be any different if it is compounded quarterly? Will it be any different if it is compounded quarterly? So prove
Me.
it. Yes.
If it's quarterly, it's mean 4. So 6. So the result is 597.81 for quarterly.
Okay. All right. Thank you. So 597, and this one is 2000 plus. I don't think this is the correct calculation. Perhaps you just, you need to check back. Okay, class, you need to check back this figure. Okay, because it's different so much. Okay, so thank you, Honey, for responding. So will it be any different if it is compounded quarterly? The answer is yes. Okay, prove it. You need to prove it with calculation, class. Okay, next we move to this question. This question actually try to prove that, when you have different compounding effects throughout the years, okay, so your amount also will be different. Okay, so meaning that the more frequent you compound it, okay, the more frequent you compound it, okay, the greater the future value would be. Okay, it's slightly higher. Okay, slightly higher. Okay, all right. So next, perhaps you can try this class. You have been put in charge of managing your firm's cash position and notice that the Bank of Oregon has recently decided to begin paying interest compounded semi-annually. So semi-annually means your M is equals to 2, isn't it? All right. So if you deposit 1,000 of, with 1,000 with the bank at an interest rate of 12% per annum. So what will your account balance in 5 years? So you see compounded semi-annually now. So you have your new I, 12% divided with 2. So it becomes 6%. For your new N is 5 years, isn't it? 5 times so 10. So replace this value, okay, in the formula of calculating the the future value. Okay, then you will get the answer. The answer should be this one. All right, class? I give you the answer there. Okay. Yes, honey. Is there anything you want to ask, honey?
No, I forgot to lower my hand, sorry.
Okay, never mind. Okay, let's try this example 3. Okay, recently Maybank decided to begin paying interest compounded quarterly instead of annually. So now they change from annually to, all right. So John is one of the customer of the bank, has deposited 5,000 with Maybank at interest rate of 10%. So how much is the balance have? The balance of John have, quarterly means your M now is become, so how is it? Your M? Much 4, thank you. Okay, so now you need to adjust your interest with a new one, which is 10% divided by 4. And your N is 20. This is 5%. So try to, substitute all these figures, new figures into the formula, and you will get this answer. Okay, can you see this answer? I provide you the answer here. All right, so that you can cross-check. All right. Okay, next we move to the PV and discounting. So what does it mean by PV here? PV is a present value, it's a value today. Okay, value to flows or series of cash flows. You want to know how much does it value today. All right. So this is one of the method on how to estimate the real value, okay, of the investment or of your business. Okay. So the process of finding the PV we call discounting. Okay, discounting. Okay, this method also can be used to calculate for the purchasing power. We want to know how much is the purchasing power that we have today with that certain amount of money with the effects from the interest. Okay. So let's say try to settle for this. How much is this $100 that you will receive in year 3 valued today? How much? The purchasing power today. Okay, with the interest of 4%. So perhaps, okay, you can calculate the PV using the same formula of FV. So FV just now is equals to PV times 1 power plus R power of I. Power of N. Okay, power of N. Okay, so how to find the PV class? You need to bring here to here, isn't it? So PV is equals to FV over 1 plus R power of N. Okay. Or sometimes can be written as FV times 1 plus R power of negative N. Okay, because you bring, the denominator on top. So the power will be negative. All right. So after replacing all the value here, then you will get, okay, then we get the $100 that you received in year 3, valid today is only $88.90. Okay. All right. Next, we move for other methods to solve for the present value. Okay, you can use the calculator, but you need to have all this information to key in. All right, so that the calculator can calculate it for you. You can have this formula in your Excel cell. Okay, and then you can use the apps to calculate for the PV. All right, you need to have all those information as well. Okay. And perhaps you can try this. Okay. How much Sarah needs to save today for her daughter's tuition fees? 30,000 in after 10 years. So this Sarah needs money of 30,000 at year 10, not now, year 10. So how much does, she needs to save the money today in order that she can get $30,000 at year 10. Okay, so the bank will give her, 8% per annum, compounded. The interest will be compounded and semi-annually. All right. So you need to first thing first find the new N and the new I. Okay, using the compounding effects of M equals to 2. Okay, start to find this new I and N. All right, and you replace all this value into the formula. Then you'll find that Sarah needs to save in her account this much in order for her to get 30,000 at year 10. Is that clear, class? Okay.
Yeah.
Okay. All right. So next we move to sorry, class. I need to take a sip of water. Okay, so we move to annuities. What is annuity? Annuity is a series of payments that are equal. It must be equal, class. If it's not equal, so it is not annuity. So must be equal and are made at fixed interval. Okay, every year, every month, every day. Okay, you cannot skip. If skip, it is not annuity. All right. For example, you need to pay for $100 at the end of each year for the next 3 years. So this is called 3-year, $100 3-year annuity. Okay. And talking about annuity, we have two kinds of annuity. First is ordinary annuity, and the second one is annuity due. All right. Talking about ordinary annuity, okay, what is the difference between these two? Ordinary annuity, the payment made at the end of each period. This is normal. This is a normal practice where we receive the payment or we make a payment at the end of the period. Okay, but talking about annuity due, the payment are made at the beginning of the period. Okay, when you start taking your loans, signing the contract, you need to immediately pay for the interest. And that's what we call annuity due has been applied. Okay, all right. Let's look at this much more clearer using the timelines. Okay, the difference between the ordinary annuity and annuity due. Okay, perhaps as you can see the payment here for ordinary annuity, you will receive the payment or you need to pay at the end of the period. Okay, however, for the annuity due, you need to pay the payment at the beginning of the period, right after you sign the contract. You need to pay, okay, immediately. All right. So annuity due will actually incur another extra interest. Okay, that's why in the formula of calculating the annuity due, you will find that, you need to add extra. You need to times with extra interest effect. Okay, so let's look at the ordinary annuity for future value first. Okay, you have 3-year ordinary annuity of $100 at 4%. Okay, so how much is the future value of this annuity? Okay, so using the formula here, FVA is equals to A. What is A stand for? This is the series of equal payment. So this is, in this case, $100, isn't it? Okay, $100. So times with all this, 1 plus R power of T minus 1 over R. What is this called? This is called interest factor. This is called interest factor. Okay, you can calculate this interest factor using the formula, or you can just get the figure from the interest factor table, like down here. Okay, from here. Okay, So I have extracted this 4% at 3 years, as you can see here, 4% 3 years. So the figure shows you at 3.1216, isn't it? So either you use the formula to calculate for the interest factor, or you use the figure from the table. It will give the same answer, okay, with the similar future value amount. All right. So it's up to you. Which one would you prefer? All right. All right. So next is, all right, class. I want to make some corrections on this example. Okay, this example actually the solution here is actually referring to not end payment, but I believe you need to change here to beginning. Okay, beginning. Okay, at the beginning. All right, because I have wrongly pasted, the questions from the original picture. All right, so that's my mistake. I'm sorry. So let's look at this example class. Bakri plans to put aside $5,000 per year so that he can make a nice down payment on BMW car in 6 years' time. So if he makes the payments at the beginning of each year and earns 8% on his deposit, so how much will have accumulated at the end of year 6 or 6 years? Okay. So this is about per year. We know per year means annuity. Okay, every year 5,000. So this is annuity. So to find for the future value annuity, you use this formula to calculate. All right. So payment times the future value interest factor annuity. You can get it from the table, or you can calculate yourself. Okay, using the formula using the formulas, all right? So in this case, it is actually extracted from the interest factor table, all right, 7.3359. Okay, and then the difference is that between the ordinary and annuity due is that you need, if you have like, you need to add, another extra interest effects because this is annuity due. How do I know annuity due? Because the payments may begin immediately. All right, so this is actually the annuity due. So you need to times with extra interest, 1 plus R. Okay, so after you have, substitute all the figures, then you will get the future value annuity at 39,000 plus. Okay, so let's look at this class, future value annuity due. Okay, actually we have covered the example earlier, isn't it? Okay, never mind. When payment, what is annuity due for future value? It means that when payments are to begin immediately, okay, not at the end of the first period. So we must therefore calculate the future value as an annuity due. Okay, in this kind of annuity, you will earn an extra year's interest. That's why, when you calculate for the ordinary annuity, like payment times the what you call this, FVIFA, okay, the interest factor, you need to times with 1 plus R, because under the annuity due, you will earn extra interest. If it is normal or ordinary annuity, so no need to times with 1 plus R, just enough until here. This is ordinary. Okay. Okay, next is I give you example here on the annuity due. So they give you a series of payment $25 for 3 years at 9% interest, which was paid at the beginning. So this is the keyword of annuity due, immediately, beginning, So it's a, indication of annuity due. So they ask you to calculate for the future value of annuity due. Okay, you need to, you can calculate using the formula like this, or you can just find your interest factor from the interest factor table. Okay, and then times with the interest, extra interest earned. because annuity due. All right, then you will get the answer, the same answer. Okay, either you use table, interest factor table, or you use the formula, right? Okay, next is future value annuity due. This is the same. Okay, sorry, this is example. Okay, so let's look at this example, class. We used a similar facts in example earlier before. So, however, we are told that Bakri plans to put aside 5,000 per year starting from now. Starting from now, this is another indicator of annuity due. Okay, they start to put aside starting from now and still earns 8% on his deposits. Okay. All right. So how much will he have accumulated at the end of 6 years? Okay, so the solution they provide down here is whether you can, settle using the formula or you can use the financial table. Okay, it's up to you. All right, 5,000. This is a series of equal payment times with the interest factor of annuity from the table, 8%, 6 years. There we get 7.3359 times with the interest factor, extra interest. Okay, because this is annuity due, so then you get 39,000 plus. All right, so next we move to the PV of an annuity. What is PV of annuity means? A series of equal payment made at regular interval. Okay, so basically the definition is the same as FVA, series of equal payments made at regular intervals, but the timing, but the process of expressing the value of today, okay, we call discounting. Okay, that makes the things different. All right. So this is the formula to calculate for the PVA annuity. This is ordinary annuity. Okay, you have the same A, which is a payment, series of equal payment, times with the interest factor here. All right, 1 minus 1 over 1 plus R, power of T over R. Okay, so they give you example, how much is the 3-year $100 ordinary annuity will be valid today if the interest factor, if the interest or the what you call the cost of capital is at 5%. Okay, so you need to calculate for the ordinary annuity. So the formula is like this. Okay, after calculating all this, then you will get this. Okay, or you can just refer from the interest factor table. Okay, looking for this 5% 3 years, 5% 3 years. Okay, let's look at together. PV, PVA. Okay, we use this table. Okay, we use this table, PVA, this one. All right. How many years is now, class? I forgot already, sorry. How many, class? How many years? Can someone respond? Mm-hmm.
3 years, ma'am.
3 years. For how many percent is now?
5%.
Thank you, 5%. 5%, 3 years. This one, isn't it? Am I correct?
Yes.
Okay, 5%, 3 years. We use the PVIFA table. Okay, so you get 2.7232. 2.7232. Okay, the times with this $100, then we get 1272.32. So you will get this kind of PV. Get the value of PV for this series of annuity. Okay, so next we look at this next example, 3-year ordinary annuity of 1,000 at 4%. Okay, perhaps we can solve them using the formula. Okay, this is the answer after substitute everything inside. Okay, if perhaps you are using the interest factor table, 3 years, 4%. Okay, 3 FVI This is PV, sorry, class. PVIFA. 3 years at 4%. Okay, so how much you will get? This interest factor, 3 years, 4%. Okay, 3 years, 4%. Okay, this 4% table is quite lagging here. Wait, okay, 4%, 3 years. So this much. Wait, okay. This much, isn't it? So 27751. So 27751. Okay. Then it times with $1,000. Okay. Payment is $1,000 here. Times with 277,123. So it's equal to 77510. Okay, whenever you solve using the formula or you solve using the interest factor table, the answer is the same. All right. Okay. Next, we move to the PV of ordinary annuity. The ordinary still ordinary annuity. Okay, class. Okay, next example is about retirement plan. Green has just retired. APF will pay him $1,000 a year for 6 years. He is to receive his first payment a year from now. A year from now. What do you think? It is ordinary or annuity due? Is this ordinary annuity or annuity due? Now, this is ordinary annuity, but why? Because not yet received. Will receive from now, not now, from now. Okay, so this is ordinary annuity. All right, so they ask you what is the PVA of this retirement plan would be. So the value of this retirement plan would valued at $4,355.30. Okay, by right, if pay 1,000 a year for 6 years, 1, 2, 3, 4, 5, perhaps 6. Okay, so by right, if you try to sum up, it's 6,000, isn't it? 6,000. This is like very rough calculation. Okay, so perhaps this you need to know how much does this value today. Okay, how much does this value today? Okay, this is the real value that you actually earn, all right, for having this 1,000 in a series equal payment. All right. Okay, so next is PV annuity due. So what does it mean by annuity due? The first payment starting at the beginning, class. Okay, the first payment starting at the beginning immediately. All right, this is so-called the annuity due. So let's look at this example. A sub $50 is paid every year for 3 years, but the first payment starts immediately. You see, today at year 0, today starts immediately, $50. So this is annuity due. Okay, you can calculate this way, or you can calculate using the formula here, class, this one. But you need to times what, class? Extra interest earned. Don't forget, times with 1 plus R. Okay, times with 1 plus R. This is annuity due. Whenever it is a future value, whenever it is a present value, when it comes to annuity due, you need to plus or you need the times with extra interest earned. All right. So you will get the same answer, class, right? 140,000. Sorry, $140.40. Okay. If you're using the interest factor table, it's much more straightforward, isn't it? So 7%, 3 years. 7%, 3 years. Let's look at 7% and 3 years. Okay, ta-da, this is the one. 2.6243, isn't it? Okay, 262. 262,26243, 2.6243 here. Times 50 times 1 plus 7%, then you will get this the same figure. All right, make sure it is same. All right. So next we look at the example here. All right. Raj has won 1 million jackpot and will get paid in 5 annual payments, where the first payment will be made immediately. So you know this is a annuity due, isn't it? Because the payment made immediately. So you know this is annuity due. All right. But this $1 million, you need to adjust because you will get paid in 5 annual payments. So each payment you will get 200,000 divided by 5. All right. So now your payment here is $200,000. Okay. Times, you want to know, sorry, what was the question just now? What is the PV? Okay, the PV of his jackpot, the PV. So this is a PVA due. All right. So the payment times with the PVIFA. Okay. 8% for 5 years. Okay. Then you will get from the interest factor table 3.9927 times with the extra interest earned. Okay. So your PV would value 862,423.20 cents. It's about $800,000, isn't it? Okay. All right. So next we move to the concept of NPV. All right, net present value. So we have covered for the present value, but what is net present value? So net present value is a financial metric used to assess the profitability of investment. Okay, profitability of investment or project. Okay, by calculating the difference between the PV of cash inflows and the PV of cash outflows over a given period. Okay, so in other words, you need to find the cash flow for each year. How to find the net cash flows is a cash inflow minus the cash outflow. Then you will have the net cash flow for that particular year. And of course, you'll be given a series of years. Okay, a series of cash flows. So this method NPV is actually used, okay, to determine the real value of a business or real value of your investment, the real, because it already considered the time value of money concept. Okay, so how to know that whether your investment, whether your decision to buy new business is a worth one, is a worth decision. So look at this indicator of the NPV. If after you calculating the NPV, okay, you'll find that there is a positive sign of NPV. So it is a worth investment decision. Okay, just accept the proposal, go for it. Okay, however, if your NPV resulting to negative NPV, so please do not even consider to take it, okay? Because it gives no value in the future, all right? So let's see how to calculate for the NPV, all right? This is how we calculate NPV. Okay, as you all know, a series of cash flows which has been discounted at R or WACC, okay, or at cost of capital, discounted. Okay, so in other words, okay, to find for the NPV, okay, from year 1 until infinity, and then minus out with the CO. CO is an initial outlay or initial investment. Okay, so let's look at the first example here. Twin brothers invested $1,000 in the Groom Car project and received a series of uneven payment over 5 years. Okay, so the payments were $100 in the first year. He received $300 for year 2, 3, 4. and another 500 at year 5. So the interest rate given to you is 12% per annum. This is the cost of capital or the required rate of return. Okay. So based on these figures, do you consider this as a worth investment, class? To know whether it is a wise or worth investment, okay, you need to calculate for the MPV first. How to calculate? First, you need to find the TPV first. Okay, you need to find for the TPV. So how to know the TPV, total present value? So you have to sum up all of the PV from each series of cash flows. So then here is a total PV, total present value, $1,016. How to get the NPV, the net one? You need to minus out with the initial investment. So the result will give you positive, even though it is only $16, but still positive. Okay, what can you say about this investment? It is the worst investment to invest it in. All right. Accept the proposal because it will add value in the future. All right. All right, let's try this class. Jaylan Limited is considering purchasing a new machine for improvement of its operations. So they give you a series of cash flow for 5 years at interest rate of 11% at cost of capital or required rate of return of 11%. So they ask you whether is this a worth investment? Okay, so how to answer this? You need to calculate MPV, all right? So how to calculate for the MPV? You need to calculate for the TPs. Where can, okay, this column, this two column is already given, isn't it? Year column and cash flow column is already given. Okay, however, you need to find for the interest factor in order for you to find for the PV of each cash flows. All right. Where can you get this? You can just, get from calculator. Just using the one that I mean the later also you can get that interest factor value. All right. And or you can get it from the interest factor table class. All right, 11%. So this is PV, 11%. We use the interest, a simple interest, this one. We use this one. It's lagging with, it will take some times. Okay. So we're going to use this table, PVIF. Okay, so let's look at this 11% column class. This one, 11% column. Can you see the 11%? It's quite unstable networking right now. Okay, so for how long? 5 years, isn't it? So you copy all these interest factor figures, okay, and put into the column here. Okay. And then how to find the PV? Cash flow times interest factor. Then you will get the PV for each cash flow. Times equals the cash flow times the interest factor. Okay, then you will get the PV for each cash flow. Then you sum up. Okay, just sum up. And then you will have this 95,000. Okay, so this is not yet NPV. This is PV, total PV. So how to get for the net present value? You need to minus out with the initial investment. Okay, here comes the initial outlay is 80,000. Can you see that? Initial outlay is $80,000. Okay, so you need to minus out in order for you to find for the NPV. All right. So NPV give you positive indicators, isn't it? 15,000 plus positive. So what should you say about this investment class? It is a worse investment, isn't it? Because the NPV shows positive indicators. Okay, it will add value in the future. All right. So next we move to the, I think at the end of our part in this chapter. Okay, Discounted cash flows. What is discounted cash flows? In firm valuation, okay, we have so many technique of firm valuation class. So this discounted cash flows, DCF is one of them. All right. So we use DCF. We use this DCF as a method of firm valuation, where this method actually applies the concept of NPV. All right. So this method, this DCF model actually used to estimate the intrinsic value of the firm. What is intrinsic value of the business? Okay, perhaps you want to buy new business, merging. Perhaps you want to consider for joint venture. So perhaps you can use this model to evaluate whether it is a good investment, good investment decisions or not. All right. So intrinsic values by this to company valued or fair priced, relative to the market price. Okay. So it also this method also provides tells you about the firm's financial health, all right, the growth of the prospect. Okay, you may know about how the business perform. Okay, and also the overall value based on the fundamental factors. What is fundamental factors? It is actually come from the internal factors. Okay, firm valuation may comes from different perspective, from two perspectives. One is from the internal perspective, which comes from the fundamental factors. The second one can be from the market perspective. Okay, and of course, for your level, as I know that you are in the first year, perhaps you need to be strong in this fundamental first. Okay, perhaps if you go further, if you study further in your in your future studies during perhaps year 3 or year 4, you will have this syllabus of corporate finance. Okay, perhaps during that time, you will learn the speculation from the market's perspective. Okay, so please be slow. Okay, try to learn one by one, step by step. So for your level, we cover for only the part. All right. Okay, so this is the steps in calculating the firm intrinsic value. What is intrinsic means the real. Okay, you want to know actually how much this business valued to you, worth to you. Okay, so the first step you need to have, you need to calculate for the projecting future free cash flows. Okay, future free cash flows. And then the second step, you need to determine the discounted rate, we call WACC or WACC, okay, weighted average of cost capital. And then number 3, you need to know on how to determine the value. Right? Number 4, you need to calculate the present value of free cash flows and this terminal value. All right, and perhaps it can comes to the determining the enterprise value. By right, actually there would be like one more section, which is you need to adjust for the debt and also for the non-cash, for the cash item, but I skipped that part. Okay, because it's very long, and perhaps this is a simple one. This is not wrong, but this is a simple one. All right. Okay. Okay, so talking about the first step, okay, projecting the future free cash flows. Okay, this is the first step for you to estimate. Okay, what is the free cash flows class? Is actually cash flows that are available to all investors. Okay, the investors may come from the equity shareholders or from the debt holders. Okay, from bond, from loan, so cash flow available after you have, settled or made any necessary payments to them. All right. So this is the formula. Okay, this is the formula actually to calculate for the free cash flows. Okay, you need to have the earnings, EBIT. EBIT means what, class? May I know what is EBIT stand for?
Earning before tax, ma'am.
Thank you. Okay, clever. So EBIT means earnings before interest and tax. Okay, because this earnings is before interest, you need to minus out with this earnings is before tax. So you need to adjust for the tax because we want to give because we want to maximizing the value of the cash flows. Okay. So then you need to add back this depreciation. Why? Because this is non-cash item. Okay, this is just an assumption. And then you have to minus out with the capital expenditure. Okay, and also minus out with any change in working capital. May I know how to calculate for the working capital, class? Can someone give me formula on how to calculate working capital? Anyone? Just ask your best friend at GPT. Oh, class. Okay, Daniel, please.
Is it current asset minus current liabilities?
Okay, great. Clever. Okay, true. So current asset minus current liability. This is how we find the working capital. So any changes in this account, okay, will be minus out from the calculation of free cash flows. All right. All right, they give you the set of future free cash flows. Okay, example here. They ask you to calculate for, they give you the information to calculate for the free cash flows. So how to calculate them? First, they have EBIT here. They give you tax rate, they give you depreciation amount, capital expenditure amount, and also current asset and current liabilities amount. So after you substitute all these figures in the formula, okay, perhaps, okay, the value for the free cash flows is $275,000. And please remember, this calculation is only for one series of cash flow. Okay, perhaps, in a real world, you'll be given a series of cash flows. All right. So next is weighted average cost of capital. Okay, weighted average cost of capital. Actually, class, for this subtopic, it is very extensive topic to be discussed. Okay, and but however, in this session, I only cover for the fundamental parts. Okay, fundamental parts of the WACC, and perhaps I just touch on the components of the WACC, which comprises from debt, which comprises from equity. Okay, so I'll discuss only the fundamental parts just to give you like an exposure about this concept. And please bear in mind as well that when you talk about, risk, okay, risk consideration, it is already embedded in this calculation of WACC, okay? But the only thing is that I will not go from scratch how to calculate WACC. I give you the final amount of WACC, all right? So perhaps because as I mentioned earlier, it's quite an extensive syllabus, okay? Because there is a chapter of WACC under the capital structure under the finance syllabus, all right? So what is WACC? It's a cost of financing and sometimes referred as a cost of capital, okay? Or sometimes they call as the required rate of return, okay? For firms use either debt or equity financing. All right, so WACC reflects the cost of equity and also cost of debt of financing. All right, so cost of equity represented by RS is calculated if firms using the equity financing tools either from preference shares or common shares, and whereby RD, which is cost of debt, is calculated for the firm's debt financing. Okay, you know that how do you think the business finance their asset class? How do you think the business finance their assets? How do you think? Accounting equation is from liability and equity, isn't it? This is how company or business finance their assets from liability or equity. So if they're using liability, they will incur cost of debt. If they're using the equity, it will incur the cost of equity. All right. So this will give cost to the financing structure. Okay. So this is how we calculate for the WACC. Okay. You have cost of debt here plus cost of equity. So how to find the cost of debt? You need to have the weighted average of your debt from your balance sheet. How much you use your liabilities and your equities to finance for the assets. You need to find the ratio. Okay. And since the cost of debt, okay, RD, okay, the interest expense are actually tax deductible. So that's why you need to minus out with the tax. Okay, and plus with the weighted average using the equity times with the cost of equity. All right, so let's look at this. Okay, how to calculate for the weightage from the debt, weightage from the preference shares, as well as the equity. So perhaps you can use accounting number or market value as a weightage, or you can just perhaps you have the target capital structure. You can use that as a basis. Okay, let's look at how to calculate weightage. So given to you is information extracted from the balance sheet class. As you can see, how does this company finance their assets? Is using the liabilities and also using the equity, this much. If you're using the book value as a basis, so you will replace this 48% as the weighted for the liability or the debt. Okay. If for the equity, so WS, isn't it, would be equals to 0.52. Okay, this is how we calculate for the weightage. If you're using the market value as a basis class, so perhaps, 43%, okay, for the WD, for the WS is 0.57, isn't it? If you're using the targeted capital structure as a basis to calculate for the weightage, so this is the figure that you must replace in, right? So this is how we calculate for the weightage. Okay, they give you example here to calculate for the WACC. Okay, they give you the amount of debt, preference shares, common equity in order for you to calculate for the WACC. And they also give you the cost of debt, cost of equity, cost of preference shares, and also the tax rate here. All right. So this example actually using the market value as the basis to calculate for the weightage. So how to calculate for the WACC class? So this is how we do the replacement, or we do the substitutions. All right. So the debt 500,000 over the total assets is 1,000 or 1 million here. Okay. Times with the tax rate is 6%. Sorry, not tax. This is cost of debt. 6% minus out with the tax rate. Okay. And then plus with the preference shares weighted here, 0.2 times cost of preference shares, 8%, plus with the weightage of the common shares, 300,000 over 1 million times with the cost of equity. Okay. So you will get 6.7%. All right, 6.7%. Okay, so next we move to the terminal value. So how to calculate for the terminal value? Terminal value is used, but before that, we need to know how does this terminal value define. The terminal value is used to estimate the value of the company beyond the forecasted period of business life. Normally, we will use the free cash flows of the final year to calculate for the terminal value. Okay, so the terminal value is commonly estimated using the perpetuity growth model, okay, where the growth rate is presumed to be constant. Okay, so this is how we calculate for the terminal value class. All right. They give you this example to ask to calculate for the terminal value. So this is how we calculate the terminal value. So at the end of the year, you will get the terminal value of this free cash flows is around $4 million. Okay, so after that, what to do? What to do is you need to sum all the PV of these free cash flows and the terminal value. First thing first, you need to discount them back. Okay, the next step is to discount them back to the WACC rate. Okay, this is how we do discounted all this value because we want to know how much this actually valued today. All right. So these free cash flows, PV plus with PV terminal value. Okay, we'll get the enterprise value. So let's look at this example here. So for the next 5 years and the terminal value at the end of 5-year period using the perpetuity, following are the projected free cash flows for JGH. Okay, they give you 5 years free cash flows. They give you also the terminal value using the free cash flows year 5, okay, to calculate for the terminal value. They give you the cost of capital or the WACC discounted rate at 10%. And then you give you also the growth rate at 3%. They ask you to calculate for the enterprise value. How much? Okay, so first thing first, you need to find the PV of the future cash flows. This is very straightforward. This is what we have done, when we're calculating the MPV, remember? Okay, interest factor at 10%. Okay, you can get this from the interest factor table. Okay, time with the cash flows, then you will get your PV for each future cash flows and the total of your present value. Okay, next you need to find the PV of the TV. Okay, first thing first, you need to find the TV first. Terminal value, how much does it value to value? 2.2 million. Then this 2.2 million need to be discounted. Okay, need to be discounted at WACC rate. Okay, so this is the PV of the TV, which is 1.3 million. Okay, in order for you to for the enterprise value, you need to sum up of all of this PV, these two PV. Okay, earlier you have calculated TPV for free cash flows 476502 plus with the PV of TV just 1.37 million, then it gives you around 1.8 million. So the enterprise value or the business value today, okay, which considering the PV of future cash flows over 5 years at WACC of 10%, isn't it? 10%, isn't it? That's now WACC or 10%. Okay. So they give you the value of the enterprise at $1.8 million. Okay. So perhaps besides the DCF, discounted cash flow model, we also have other approach to evaluate the firm's intrinsic value. Okay, among them is this 5, okay, DDM, dividend discounted model, earnings-based valuation, price-earnings ratio, price-book ratio, price-sales ratio, and perhaps, we'll not cover this as perhaps I just been given this topic DCF to cover it. Perhaps, just for your personal knowledge about, the other approaches that you may use or you may consider to calculate for the intrinsic value of the business. All right, I believe that's all from me for lecture today to cover for DCF topic. If you have any inquiry, perhaps you can just contact me through my email. Okay, this email. Okay, with that, I think I'll hand over the session back to Dr. Putu. Thank you.
Okay, thank you, Dr. Anna Rusli. Actually, I'm not yet Dr. Anna because I'm on my PhD program on at this time.
Okay.
Okay, thank you very much for your insightful presentation and today's lecture, and I'm sure our student has learned a lot from you today. And thank you for the attention of all participants. And maybe this is the end of the second session. And next day, we will meet again in the third session about financial management. Thank you very much, Dr. Anna, for
Thank-
today's lecture.
Thank you, Dr. Putu, and all the best to all students. Okay,
Yeah. Yes. Thank you.
you're welcome. I think that's all for today, isn't it? Okay, thank you. Thank you, guys. Bye. Take care.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.